July the 27th, 1995, 26, excuse me. Rianne and Bob are getting ready to leave for our mission service, and we've just finished our family reunion. During the family reunion, and just before, I should say just before the family reunion, I spent several days going through all of the junk and mementos that I've kept over the years and throwing away the things that weren't useful anymore, but reminding myself of a lot of things that I had that represent quite significant milestones in my life. So I kept the ones that were really the most important to me, I felt, and made a museum display that everybody looked at and quite enjoyed. And I decided before I packed them away, maybe forever, because who knows, I may not be around for a long time or may not have another reason to unpack them, I'd make this videotape to tell you a little bit about what they mean to me and the events in my life that they're connected with. And so this is going to be an attempt to do that. And I'm going to start off with two things here that date from long before my personal time. Here's a child's slate that dates from back before I was born that we somehow got to me from Aunt Caroline's old home, my mother's old home in Newton. And it's actually a piece of slate stone in a wooden frame, and you can see it has a crack on it, but it's what the children used to write on with chalk and make their own exercises. In fact, it had this capital A and small a, and it was probably for writing practice, but it's actually a piece of stone about 1/8 of an inch thick, and it's quite heavy as a result. I have another thing, and I don't know how I got it. It's a stencil. I don't think you can see the name on it, but it's actually a brass stencil that has been cut out with an elaborate decoration and the name Dora Christiansen. And what it was for, of course, is that you took an inked pad of cloth, you laid this on a piece of clean paper, and you rubbed across it carefully, and it would reproduce that name on the paper to be sort of a letterhead or something to personalize it. And so this Aunt Dora was my mother's great aunt. And so this is perhaps close to 150 years old. And is a piece of beautiful craftsmanship that I wish you could see. Actually, it's a metal steel frame with this very thin brass folded over it tightly so that it makes this pretty decoration. The first thing that I have of my own is kind of a strange thing. It really isn't dating back to my childhood, but the memory dates back to my childhood. What it is this big dump truck. This is a really fancy one, and it dates from the 1960s when Rianne and I were shopping one Christmas for Christmas presents for the kids. I saw this, and she remembers me saying that I really wished all my life I had had a big truck like this. Now, this was in the days before Tonka toys and these great big giant ones that we now have. But this was made during the 1960s. This is imported from Japan, and it's really quite a machine. All of these individual pieces are folded up pieces of sheet metal that are carefully inserted into the frame And so it's made of hundreds of pieces of sheet metal carefully folded and joined together. And it has a friction motor in it so that you can actually give it a push. It goes by itself. And then it has this real neat dumping feature, and I'm going to pause the camera and get it full of something so you can see it dump. Okay, now I've got it loaded. I was going to load it with these foam plastic peanuts, but I couldn't. We've thrown them all away, but I have loaded it up with forks, paper, plastic forks from our leftover from our reunion, and so I'm going to dump it. Here we go. It's going to go, and you just push this button, and it lifts up and dumps it slow. Now the reason I'm telling you about this is because the thing that came to my mind when I saw this back in the early 1960s was because when I was about 5 years old, my mother's younger sister, Verda, had finished college, was on her own, and was employed and making quite a lot of money, at least she thought she was. And so she decided she would give me, she wasn't married yet, and she decided she would give me a very special present. And so she bought a big metal truck. I remember that it even had a battery and headlights that worked. That was the main feature of it. In fact, the little light bulbs were even shaped like headlights, which was what had been done to publicize such things at that time. And so you could take it into a dark room and turn the lights on, and here would be these headlights of this truck. I was absolutely fascinated by it, just thrilled by this big truck that I had. But there was such a tension between my mother and her sister at that time that my mother felt her sister had given that to me just strictly out of spite, and who knows but what maybe that was the case, and that it was an attempt to show off her affluence and compare it with my mother's poverty since my mother and dad were struggling so hard because he was still trying to finish his college education. But my mother never could feel comfortable about having me play with it on an everyday basis, and so it got put away and I never saw it. But I remembered that. Then the next time that something happened, I remembered that a few years later, probably 1938 or 39, just as we were getting out of the Depression, some friend of my parents was going to try to make his fortune by having invented a electric motor driven Caterpillar tractor. It was made out of one of the Marx wind-up tractors that were one of the early Marx toys and were made for 30 or 40 years, a wind-up crawler tractor with rubber treads. And he had converted one of those to motor operation with a motor to run each track and a switch box so that the motors could be reversed and go forward, and that lets you back it up and go forward and turn it. And he brought it to my parents' place and said, "Your son is about the age of young people that I would like to sell this to. Would you keep it for a while and see what his reaction to it is?" Well, again, my mother was very uncomfortable with that and was afraid I was going to damage it. And so she didn't let me play with it very much. I remember, though, one night it was underneath our living room sofa. And somebody came to see my parents, and after I was supposed to be to bed, I snuck in and got behind the sofa, and the control box was right back there, and so I started it up, and it started making a noise and ran right out into the feet of this person and scared him to death. And after that, the tractor disappeared. So anyway, all of those thoughts were in my mind when I saw this truck in the store, and I said, oh, I've always wanted a truck like that. Well, my dear wife, not knowing all that background, and probably even if she had, decided to get me that truck. And so I got it, and so I've kept it ever since. And I bring it out every few years and show it off, and so now I've played it for you and shown it for you. As a matter of fact, it's a rather significant piece of equipment, because this would be an extremely expensive thing now, because so much handwork has gone into it, all of these folded pieces of metal. Now, of course, such a vehicle can be made very inexpensively, because just be injection molded out of a few pieces of plastic that would then just be slipped together. And so it belongs to an earlier age, when a lot of craftsmanship of people living overseas in countries where they only got paid a few pennies a day were able to make fairly elaborate things. Now we're going to go ahead with most of the more regular things, kind of chronologically. We may be interrupted because I'm babysitting for Rachel right now, children sitting, and probably can't continue this, but we'll try. One of my very first introductions to technology was the radio. Radio was just, and electronics, they were just coming in when we were young, and of course they had already progressed beyond crystal sets to vacuum tubes by the time I was growing up. But crystal sets were still the way you got started when you were a brand newly getting acquainted with electronics, because all you had to have was copper wire and a crystal and something else to put it all together. And so I started making crystal sets when I was little, and this is the most elaborate one that I made. This one was after we had progressed beyond having a little crystal of selenium metal cast into a piece of lead, and then putting a wire, touching a wire, a feeler that was called a whisker, to the crystal to get a signal through it. And this was made for an actual diode that you bought and put in between here, between these two clips. And then this was for the antenna, and this was for the ground, and these were for the earphones. And this I made as an attempt to make a really fancy one with a tuning coil. You could either tune with a condenser or with a coil, and I didn't have a condenser yet, and so I built this tuning coil with a slide wire and with a little feeler that went along the top of the coils and tuned to a longer or shorter coil to change stations. It didn't work very well, but I did get some stations, and that was one of my first actual engineering constructions. Before I went further into engineering, of course, I got into scouting, and scouting, of course, not only gave me the skills for outdooring, but also introduced me to the world of work and careers and the various other kinds of things that a person could learn to do. Here is my scout belt, And this one happens to have, I see, this is not the original one that I had when I was young. This one, I see, says that it has a 23 karat gold plated buckle. And so it may not even have been originally my Scout belt, but I had one of that same type, which, as you know, has this clamp that adjusts it to whatever length you want. And here are my main Scout badges. Here's my Eagle badge, my Life, my Star. I don't have a first class badge, but here is a second class badge. And here's the little tiny eagle that I was given to give to my mother so that she could wear it on her dress. And here also is a little second class badge that my mother wore when I was a second class Scout. I'm proud of my eagle. I worked hard to get it, and in fact I had a bronze and a gold palm. I don't know where the other one is, but that's the gold palm that I wore. I notice in this box also I'm keeping a name slip. Now we have, of course, these paper stick-on names or a plastic badge, but this was a badge in a brass metal case that my father wore at a scientific convention that he went to. He became a member of the Sigma Psi National Honorary Scientific Fraternity for some of the work he had done with Dr. Thomas, and he went to one of their conventions and brought that badge home, and I somehow ended up with it in my collection. I have other Scout things, but I just mostly can have here two things. One of them is are the maps that I made. I thought it was for pioneering, but my mother's note says it's for pathfinding, merit badge. And I made an ink mechanical drawing of Taylorsville, Utah, my home right on the beginning of Taylorsville, and then the road went up 48th South to Redwood Road, which is where the school was that I went, the city cemetery, and our church was right here a little ways up from the road on the other side of the road. And then Taylorsville officially took in the area clear to 40th West, which is where Kearns now starts, and went clear over to 35th South. When I was growing up, there was a railroad track for the electric interurban train that ran from Payson. Actually, it ran to Salt Lake, and then another company took over from Salt Lake and ran clear up to Logan. And an electric interurban train ran all during my childhood on those tracks, just about at 20th West Street. And of course that's gone now. There was a Magna branch, and the railroad was still there up between about 37th South, but that interurban had quit running by the time I was young. I have this here, and it's significant because I made this map as part of the requirement and submitted it to Brother Rex Mackey, and he turned it down, and it was a tremendous blow. I had put a great deal of effort in. I had traveled on every one of these roads to measure them out and decide just where they were and what size, what distances they were, and I'd drawn the map carefully. And he turned it down because I didn't have the extension of those roads as to which ones went on and which ones did not go on, which ones continued on further outside of the map and which ones did. And so I had to go, and in fact I went one day and it started to rain just after I had left, but I was so anxious to get done that I continued on. So pardon me, I'll have to interrupt. As I say, Brother Mackey refused to accept this. I think he just wanted to be sure I did a good job. And so I had to go all around this perimeter and find which roads continued on and which roads did not, and then come and ink them back in. This was made by pen and ink in the old-fashioned way. I also, as part of the requirements for that merit badge, made this drawing that I doubt if you can see the details of the 1.5 acre property that we lived on, and the plan view of our house roof, and here's the barn and the shed that are still there after 50 years. Drawn by Robert D. Collier, a scale of 1 inch equals 2 rods. Map of Collier Farms Incorporated, Taylorsville, Utah. Scouting was an extremely valuable experience for me, as it has been for many young men, in introducing us to many different things that we needed to know and that were options for us to choose as careers. As a matter of fact, my map-making experience here and my experience with drafting were probably quite significant in orienting me towards engineering. And as a matter of fact, it would only be about less than 10 years till I was actually employed by Brigham Young University as a lab instructor in civil engineering in the surveying lab. I didn't become a civil engineer, but I taught the surveying lab to all of the engineering students. Another interesting thing that came along in my high school time was my exposure to science. Because my dad was a scientist, he worked as a chemist during my childhood at the American Smelting and Refining Company Research Laboratory, Agricultural Research Laboratory. I was often over there at the lab and of course learned quite a lot about chemistry and physics. Dad's great love was physics, but his work was chemistry. While I was in high school, we had to do a research paper on chemistry, and what I decided to do was to make a research report on the metal indium. It's one of the basic elements and is a very unusual and not very common metal, and so I decided to make a research report on it. And I found that at the lab Dad worked, they had an actual sample of the metal indium, and so Dad got permission to cut a small piece about the size of a third of a dime, so that I could put it in a glass bottle and actually attach it to my research paper. I got an A on that paper and I enjoyed it very much. That sparked an interest in my finding out how many of the actual basic elements they had there in the lab or that I could collect. And so during my last years in high school, I just got onto a personal project that resulted in this collection of the basic elements. Turned out to have some interesting implications. From the lab itself, of course, I got such things as tin. Here's some samples of tin that I just was able to get from the lab. There's manganese, crystalline manganese. Copper, of course. I got some little thin sheet copper. And I even managed to get permission to get from the lab a sample of gold. Of course, gold at that time was $35 an ounce, and this is probably a quarter of an ounce. So it still, even at that time, represented $8 or $9. But now that gold is worth nearly $400 an ounce, that amount of pure gold, which that is, 24 karat gold, is worth nearly $100. I also have such things as iron, which I just used some nails that I cut off. Then I have lead, some lead sheet, as well as lead shot. Here's molybdenum. That was in a powder form. Here's titanium. A very light metal. And later on, many years afterwards, when I was in the Air Force and aerospace industry, titanium became very common for aircraft structure, and I have this much larger piece of titanium. It's still very light. It's a little lighter than aluminum, and yet is very, very strong and used much today. Here's a sample of chromium and silicon. Of course, now silicon is very common in computer chips, but it wasn't common at that time. I also have a sample of platinum, and that's probably $30 or $40 worth of platinum. Here's silver. And I got that sample by going over to the lab where Dad worked, and with an oxyacetylene torch melting a dime. So that's actually a dime melted down. But this collection ended up I ended up getting so interested in it that I began to collect some unusual and exotic ones, not only the indium that I found, and gold and silver and platinum. But I decided to see if I might collect some things that were very uncommonly collected. Of course, you can't very well collect oxygen, nitrogen, and the gases. That would be very difficult. But one of the unusual elements that I did collect is bromine. Bromine is a liquid, a very highly corrosive liquid that has to be sealed against air. And so I found that bromine is kept in vials that have a glass stem, and water is kept on top of the bromine, and then the glass vial is completely sealed by actually melting the end each time you use it. So I had my dad make me a vial from a piece of glass tubing, and I got a sample of bromine, this dark material at the bottom, covered with water, and then had him seal the vial in a high temperature flame. And so I have now for 50 years had this sample of bromine safely sealed in glass in my collection. My most unusual thing, during the late 1940s, one of the visitors to their laboratory happened to be an expert in nuclear work and in uranium, and so he brought me two very unusual samples. The first is an actual sample of the metal uranium, which I made a lead case for. It isn't really all that necessary to keep it in a lead case. know if I can get it out, but it would be worth getting out so that you could see it for this purpose. So we'll try. I have put it in covered it with a piece of aluminum foil, and I have it in its lead case. It doesn't want to come out very easily. There it comes. So now I'll unwrap it for the purpose of this. Uranium is very heavy. It's heavier than lead. And so we have this sample of uranium wrapped carefully in aluminum foil that is about as thick as a 50-cent piece. And of course it corrodes, so it's kind of rusty. But one of its interesting features is that if you scrape it, you can get sparks. That's just scraping it with a knife blade. It gives off sparks. So that's U-238 uranium, about an ounce. Another sample that man gave me was this sample of fused sand. It's called trinitite, and it's slightly radioactive melted sand that the desert floor was covered with under the first atomic bomb blast test there in the New Mexico desert. And so those who were there went out and picked up this melted sand on the surface and gave it away as souvenir gifts to people. So I have now still this collection of perhaps 30 or 40 of the basic chemical elements. And we'll put it aside over here. Continue on. Well, my interest was early in chemistry, but then gradually it moved more to making things, which I didn't know was engineering, but turned out to be what led me into an engineering career. One of my first interests was not only radio, but electricity in general. My interest in radio and electronics never did go very far because I didn't have anybody to really teach me the basics and help me through a logical study. So I made a number of radios and spent a lot of money on radio tubes and parts and various things, mostly to make electronic items that were described in the Popular Science and Popular Mechanics magazines, but I don't really recall that any of them ever worked, and so I eventually got kind of discouraged. On the other hand, one of the early things that I did was to follow instructions in the magazine to make an electric motor, and it worked, and it worked very well. And so I kind of made a hobby of making electric motors. And one of the first one that I made used an ordinary cork for the armature, and it worked so well that I decided to make a really elaborate one. I was going to make an 8-pole motor, an 8-pole motor with 4 windings. I actually only made 3 of them, so it was a 6-pole motor, but the end of each wire for each of those is connected to one of these pieces of wire that's stuck into the end of the cork. And so by putting this between the poles of a large electromagnet, or a large permanent magnet, and touching 2 wires to the sides of this group of wires, this would start up and go. I'm sorry that I don't have time to set it up for you now, because this one really went well. It started, I didn't have to spin it to start it, I could just touch the wires and it went and turned fast and worked very, very well. I made several motors, and in fact later on, when I was late in high school or early in college, I ran across in the war surplus stores, which I enjoyed frequenting, a bunch of meters from Aircraft Instruments primarily, and these were equipped with a heavy, high-power permanent magnet, and so we used to get these meters and take them apart for the magnets. One of these, since they have a little coil of wire that's the meter movement, I decided, well, I wonder if I could actually make that into an electric motor. And so I snipped the wires carefully and set it up with some delicate little wires to touch it, and actually took the spring off of it so that it would turn freely, and actually turned this into a working electric motor. I can't believe that I did it. It took some very delicate, painstaking work, but it did work, and it worked successfully, and I'm quite proud of it. That got me going towards what you could say was an engineering career. The thing that really got me going in engineering, though, was my experience with the weed burners, and that occurred in my early college time when I had actually decided to be an engineer, but it confirmed my interest in mechanical design and in building and designing things that I'm still quite proud of. I'm sorry that I don't have the weed burners that I built. I saved them for many years, but they were thrown away during the time that we were getting rid of all of our extra things in order to move to Oklahoma in 1983. And so I don't have the weed burners, but they were one of my significant design accomplishments, because I was able to design a much better weed burner than the original ones that were on the market, to be powered by propane, using actual liquid propane directly from a tank and having an output of approximately 1.5 million BTUs per hour, designed to do huge areas of weed burning. Particularly then, the aim was to burn the canal and ditch banks in Utah, which were open and used for irrigation, and which in late summer got covered with weeds. I also built a large tractor-mounted boom to hold 5 of those burners to try and really do the job in mass production. It worked well mechanically. It was just that, of course, with 7.5 million BTUs going out, it was hard to control it and hard to keep from spending way too much money on the gas that you used for the amount of work that you did. But from an engineering standpoint, it was highly successful. I used a car rear axle as the main support for the boom, a aircraft long screw aircraft actuator from aircraft wing flaps hooked to a car starter motor as the device to raise and lower the boom. And I'm really quite proud of it, and it worked very well. But this was some of the earliest things that got it started, was my designing of electric motors. Let's go on into college work. At the time that I was well, now we're going to go into engineering school, here I have a box of my father's drafting instruments. There are not too many of them here, but they're in a mahogany case, and these are instruments I know he bought used, but was still very proud of. And interestingly enough, the main thing that is here is several drafting pens. Now, even at the time that I was going to school, they had largely quit using these drafting pens because they're so much trouble and difficulty to use. What they are is two metal pieces that have a rounded tip and that are screwed further apart or closer together by this little thumb screw. And you dip India ink out of a little bottle with a little tapered cup, tiny tapered cup sort of thing, and you touch it in between here and it will fill up this space between the two, and then you adjust the width of the line by how far apart these are, and then you touch it on the paper and draw it carefully across. I'm not even going to do it because it's so much trouble to set up, but you had to go very, very carefully, of course, or the ink would run underneath the straight edge you were using or whatever. But then there are several pieces here that are also extension arms that fold and that you can attach into one another like this to make big circles and draw various shapes. My father took drafting, although he never did plan to go into engineering. He was always a scientist and was in physics, but he still had to have these drafting instruments. Over the years, I did quite a bit of drawing of the general type that this map represents, and collected a number of interesting drafting instruments. Some of these templates for drawing hexagons and squares and triangles. And here is an adjustable triangle that you make various special angles with, and the angle is shown on the device. Then of course regular triangles. Here's another smaller and very fancy adjustable triangle that I used for some time. And here's an interesting little gadget. This is a straight edge with a roller on it so that you can put it on the paper, draw a straight line, then just roll it, and you can draw parallel lines. So that's a very interesting gadget. Various other instruments. Now, of course, that's almost completely a thing of the past because of computer-aided drafting, which can do all of this very much faster. Recently, our friend Mr. Gillum, up on the hill behind us, decided to make us a gift of a table, and he made very elaborate carved posts to hold the table up that he turned on his lathe. And because he's an engineer and has computer-assisted drafting, he drew those posts with his computer all in great detail, dimensioned them all just by punching a button, and the whole thing was drawn in great and elaborate detail. So this is a thing of the past, but I still have these drafting instruments as souvenirs. Another thing of the past that went almost while I was in college myself, just beginning to come in, we did all of our engineering calculations by means of slide rules. And so one of the first purchases of an engineering student would be one of these detailed 12-inch slide rules. The slide rule works by logarithms. Since you may never see one, let me explain. Here is the figure 1, here is the figure 2, here is the figure 3, 4, 5, 6, 7, 8, 9, 10. The distance between 1 and 2 is the same distance as between 2 and 4, so that if you have two scales, they're identical scales, one's on top of the other, and it's a machine for graphically doing multiplication. In other words, you put on this lower scale the 1 on the upper scale at one of the numbers we want to use. Let's say that we want to multiply 2 times 2, okay? I slide the slide over until the 1 on the upper scale is above the 2. Then I can say 2 times 2, and sure enough it's 4. 2 times 4 is 8. 2 times 5 is 10. So the difference between 1 and 5 is the same difference as between 2 and 10. And so you can sit here and you can say 1.85 times 2.3 is 6.1, or 2.22, see there's 2.2, and then the next little line is 2. 2.22 times 3 is 6.66. Good joke that I was told was that one of my professors was watching a new engineer running his slide rule, doing a bunch of routine calculations, and he was talking out loud while he was doing it, and he would say 257 times 33 is 600 something, and going on and saying those and writing it down. And then suddenly he came to 2 times 20. Well, without doing it in his head, he just put it down there. 2 times 20, 39.98. Call it 40. This is a Pickett and Eckel aluminum slide rule. Some people felt you had to have a wood slide rule, but Pickett and Eckel made a fortune making aluminum slide rules. And this one is a standard college rule with a leather case that I have ended up, I believe I got this in a flea market or something like that many years later. But here are 2 slide rules that I used. This is the Pickett and Eckel 6-inch one that I used for all of my college calculations. It's small and light and fits in the pocket, and so I used it all the years I was going to college. Then after I was out of college working for the General Electric Company, we had a visit from some engineers from a Japanese company, and as a token of appreciation for our spending time with them, they gave me this beautiful bamboo slide rule, which is just a beautiful slide rule with all engraved lines and numbers, and made from little thin slivers of bamboo, which are very strong and dimensionally stable, and so it's a very high quality slide rule that I'm very proud to have, but of course it's not just a museum piece. Another interesting slide rule, this circular slide rule was invented many, many years ago in the 1920s or 30s, And it works the same way. You move one index to the 1, then move this index to the number you want to multiply by. And let's say we want 2 times 2. Okay, there's 2. And then you move the, I'm sorry, I'm doing it wrong. Take this long one and you put it on 1. And there's a little special line there to see that you do that. And you hold that, put this to the first number. And let's say I want 3 times, and there is, you put the second one on 3, and then it is held clamped to this one. And now if you'll turn this one over 3 times and put this at 2, then you can read down here, and it is moved over to 6. It has room for many more scales. It's round and isn't as long as the 12-inch rule. It has room for another set of scales over here for sines, degrees, and tangents, and so on. However, this just never quite caught people's imaginations. It's a very good slide rule, never quite achieved the success. Was always just the other kind of slide rule, and a few oddball people used them. While I'm talking about that, let's jump ahead a little further. It wasn't very long before I got into the aerospace industry, and that, like many other industries back in the days of slide rules, you would find companies publishing special slide rules. Here's one on multiple event probability. It's just like that circular slide rule, works in the same way, and is used for all kinds of special calculations for solving. This one solves particular mathematical formula by means of this specially made slide rule, and it was given as a gift from the Honeywell company. And here is a similar slide rule type thing that had some interesting conversion scales and some interesting information about helicopters that I got while I was working with General Electric helicopter engines. And this is an example of, here is a regular slide rule scale at the bottom of it, and then all kinds of special conversion scales and other information, plus on the back some information about all the different kinds of helicopters that General Electric engines were used in. All of this has now been done away with in favor of computer software, but it furnished a definite need. And here is a 1957 aircraft propulsion data book, which has all kinds of information about mathematical calculations having to do with engine design and rocket performance and weights and measures and all other kinds of information. Even includes an atlas in the back that was given out to customers of General Electric Company. Well, we're going to go on now to some other interesting gadgets I have. This is probably one of the most important early designs that I did. I got the idea of building a direct reading fuel consumption meter. In other words, not only how much fuel my car was using as I drove along to just read it right on the dashboard, but also to actually have a scale, kind of like these slide rule scales, that could convert gallons per hour usage, which is what this would read, to miles per gallon. I'm really pretty proud of this. It's a direct reading flow meter was actually put into the fuel line. I built it after I discovered, I realized that rather than taking the fuel line between the gas pump, fuel pump, and the carburetor, which would be under pressure all the time, and that meant you would have pressurized fuel inside the car, I could put it just as well in the fuel line from the fuel tank to the gas, to the fuel pump, and that meant it would always have a vacuum on it. So that if I ever got a leak, all that would happen is that air would leak into the gas and I would see bubbles in the line and know that I had a leak. So I decided to make one. I cut the gas line underneath the car, put a piece of vinyl tubing, then it was called Tygon tubing, but we knew that it was excuse me, able to withstand the effects of gasoline. And so I put the piece of tubing in the gas line, ran it up the firewall just in front of the dashboard, drilled a hole through the dashboard, brought it underneath, brought it up the dashboard, and mounted this gauge on the dashboard, connected right here to the bottom. Then here is a specially blown tapered glass tube. I had a skillful glass blower at school blow me this tapered tube. Then I went down to the dime store and bought a inexpensive necklace with all different sizes of red glass beads, and I practiced hooking this tube to a gallon can of gasoline, bringing it up through, starting up a siphon and running it down into another one, and having a little clamp on the tubing, and tried different sizes of beads until when I was running from about 1 to 5 gallons per hour, that glass bead would float in this tube at a higher or lower level, and then by running the gas from this higher can down to the lower can and timing how long I was running, how long it took for a gallon to run, and where the bubble was, I was able to calibrate it. And you see this has a red glass bead in it. I painted the back side of it so you could see the ball floating up and down, and that made this into a flow meter that I could then mark on for 1 gallon per hour, 2 gallons, 3, 4, 5 gallons per hour. But then what I really wanted to do was put this rotating tube over it, and so I have 35 here. That means 35 miles per hour. If I was going then at 35 miles per hour, and it was floating up right at this green line, at this red line, that would represent 20 miles per gallon at 35 miles per hour. If I sped up to 45, then I just turned this around until 45 was showing, and the red mark is up here, and that means 20 miles per gallon. Here are green marks at 15 and 30, or at 15 and 25 miles per gallon. Here are yellow marks at 10 and 30, and here are green marks at 5 and 35 miles per gallon. And so I could turn this around to as far as 65 miles an hour. And by setting at that speed, then I could watch the ball and know just exactly how much gas mileage I was getting. Having this gauge mounted on my car gave me the opportunity to, as a matter of fact, get one of the interesting bits of college credit that I got by taking a chemical engineering course in which it was a graduate level research project to determine the effects on fuel mileage of water injection. By that time I had enough experience with weed spraying that I had learned quite a bit about emulsifying agents. And so I got the idea that I could use emulsified water and mix with gasoline and see if that increased gas mileage. So I presented a proposal to the chemical engineering professor and got approval to go ahead and would get 2 credit hours for running this research project. So I just cut this line. I had this mounted on my dashboard. I cut this line and put a piece of loose tubing on it. Then I would mix up a gallon of gasoline with water, a small amount of water emulsified in it, set it on the floorboard beside me, and have it running up through this flow meter and then running to the carburetor, and then I would just simply read directly what the gas mileage was for this mixture and see if I would get more or less gas mileage for various amounts of water, because there's a lot of talk of water injection. Water injection was used in aircraft primarily so that they could develop more power and wouldn't develop knocking, but I wanted to see if it would actually increase gas mileage, but it didn't. And the more water you put in, the less gas mileage you got, which isn't too surprising. But it enabled me to get that special credit for doing that work with this flow meter. And I ran this flow meter for a number of years on the dashboard of my car, and it was quite fun and always worked well. Now those vinyl tubes are all brown and hardened, but it would still work just fine, and it could be put in a present day car if we wanted to. Well, let's take a break and just do a little bit of trivia. Here's a little puzzle that I somehow picked up. There are 2 identical pieces, and you're supposed to figure out how to join these together to make a pyramid. And as it turns out, of course, you can try all sorts of things, and they don't seem to go together, but then all you have to do is just go like, whoops, this, and there's your pretty pyramid. I have another interesting thing here, and it's a wristwatch. And this turns out to be the first watch that I owned of my own. Virgil Stedman, our next door neighbor from whom I eventually bought Rayanne's engagement ring, told me that he had come across some war surplus 17 jewel Elgin wristwatches, and that he knew from personal experience that that's one of the best watch movements that has been made. And he picked them up for almost nothing and was selling them, going to try to sell them for $15 or $20 a piece, but he found he couldn't sell them very well, and so he gave me one for $5 because they have a 24-hour dial. They have been made for military service. They had a luminous dial. You can see it glow in the dark, but it's also a 24-hour dial. Well, I thought I could enjoy that, and so I wore a 24-hour dial wristwatch all through college, and it worked without trouble at all. I believe he cleaned it once for me. That cost as much as the watch had cost, $7 or $8, but it continued to work. And I used it until electronic digital watches came out, and then I retired it and had it here in my souvenir box. But you know, when I got it out and wound it up, it started working. And this morning I set it at 10 o'clock, And now it's 2 o'clock and it's right exactly on time at 1400 hours. So here it is, 50 years later, able to just be wound up and run just fine, and it's running correctly and accurately. One interesting feature of it is that when you pull the stem out to set the time, it stops. And then when you push in on the crown to set the time, that gives it a kick to start it up. And that was used, of course, in the military, because they would say, synchronize your watches. And so the person doing the synchronizing would say, okay, it's now 2 o'clock or whatever it is, 0400 hours, exactly now. And then everybody would have them set, and they'd push their stem in, and their watches would all start off at exactly the right time, which they needed to do to coordinate military operations. And so this is a running watch. Somewhere during college, I recall someone made this piece of wood, sawed a single piece of wood with holes drilled and all sawed around so that I had a single piece of wood sawed into my name. But I've long ago forgotten who that was. Right after leaving college, I went and worked in the aerospace industry in California for 6 months, and then went into the military service and became an aircraft maintenance officer, spending 9 months training at Chanute Air Force Base in Rantoul, Illinois. We went there in November of 1957. Interestingly enough now, in September of 1995, we're going right back to the Champaign-Rantoul area to serve as missionaries, which will be quite an interesting experience. I went into active duty in the Air Force. I have here my old Air Force officer's cap, still fits, several metal bars. There's the gold ones for a second lieutenant, the silver one for a first lieutenant, a couple more, a larger one for shirts and a smaller one for use on the jacket. There's my Air Force belt, which is also one of these web belts with a sliding buckle. And of course, it was built for a 32 to 34 inch waist, and I'm now a 36 inch waist. But I have been up to 38 and I'm now down to 36, and may well in the next few years drop back to 34. And I used that belt all through my Air Force time, and it's still a nice clean shiny chrome belt buckle. So I imagine I'll keep that around to remember me by. I also have a couple of Air Force insignias and a couple of name tags. And the final one that I had, which was the common engraved plastic one that you now have. The
Stop a minute. Go ahead. Sorry.
Sure, I'll stop a minute. Well, now we're going to go out of the Air Force and on into the world of work. And I don't have a lot of souvenirs, but a few that are worth mentioning. This one's a rather curious one. I went to work for General Electric Company, and after a year's training program, and I guess one of the things that I have from that training program is a copy of the instruction manual for the ship propulsion turbines, steam turbines, that I edited when I was in the instruction book section. I then went to work at Linden, New Jersey, where we built test stands, and one of the things that I was involved with was building a helicopter engine test stand that had to absorb 1,200 horsepower. And the way we absorbed that was to connect the helicopter engine output shaft to a very large turbo supercharger that had been built by General Electric for piston engines, and it would absorb the 1,200 horsepower. But we had to control it so that we could unload and load it, and I had a hard time finding a valve that was 10 inches in diameter and would open and close, because it needed to be lightweight. Any valve that's 10 inches and can stand any kind of pressure is usually weighs 400 or 500 pounds, and that was more than our whole test stand weighed. So I ran across these diaphragm valves that were a nylon sleeve, and you clamped the two sides of the sleeve and then rotated them in a different direction, and it closed an iris and opened it up, and that worked. But it was such a heavy load on the thing, with that screaming air going through it, that they really didn't last very long. So it wasn't satisfactory for a long-term answer. But I still have one of those sleeves that we had for those, for that huge valve that controlled the turbo supercharger. Well, I'm going now to talk about the next things I have, which are a lot of talking for a little bit of material. Here I have a little tiny piece of metal. I'll bring it up closer so that hopefully you can see it. It's shiny on this side and curved, and this side it's brittle and gray because that's a broken edge. And here's another shiny surface coming up at to a sharp point, and then the back side is another broken surface. That's all that's left of a perhaps 5-ton solid piece of very expensive, very high-strength tool steel. When I went with Mr. Ormond as chief engineer, he was already in the business of making what are called flexure pivots. They are hinges that move only a little tiny ways, but do so without friction because they're actually springs that bend, and they are used to make electronic load cells accurate. Electronic load cells are a rod of iron with strain gauges on it, and as you pull the iron, the strain gauge tells you how much strain is on the iron's experiencing, and you can translate that into load. But if you don't pull it without any twisting, then you get errors. And so to get rid of the twisting, you have to put these expensive things called flexure pivots. Well, we had a good business making those flexure pivots for various testing jobs, especially when building equipment, heavy-duty equipment and scales and so on. And then NASA came to us and asked us to build flexure pivots big enough to take the full load of the Saturn moon rocket engines, 1.5 million pounds of thrust, and they wanted to measure that accurately. Mr. Ormond said he could do it. He always said he could do anything. But that was going to require the casting of the largest blocks of this particular high-strength tool steel that had ever been cast, and the company was not at all sure they could cast it in that big a piece and still retain the full strength. Well, he asked them to do it. Then we hired some machinists with huge milling machines to drill the holes into those to make, in effect, narrow webs in the middle of the block. And then we went to other shops that had huge metal band saws, and they sawed the wedges to free up those webs. And I wish I had my pictures somewhere in my files. I have photos of that machining being done. The final piece of steel was about 2 square feet. Well, as I was saying, we built these huge flexures, and they were to support 1.5 million pounds, and they were all heat treated and all finished. Huge chunks of iron, several tons, and I was sent up to the University of California at Berkeley to test them. That meant putting them in their huge 6 million pound capacity testing machine, 10 stories high, with huge crossheads, one that lifted and the other one that stayed still. And one of them was up 3 stories, so we were lifted up with a crane 3 stories high, or we lifted the flexure up, brought the other one up, hooked it on, and then I got up on that huge crosshead 3 stories off the ground, right next to the flexure, just with my back against it, and with my little strain gauge meter, run by batteries and with these wires going to the flexure. We started it up. We were to stop at 500,000 pounds load, and then 1 million pounds load, and then little short steps after that. Now we're going to stop at 750,000 pounds also. So we ran the load up to 500,000 pounds. The man called out, "All right, we have 500,000 pounds load." And I checked all of my strain gauges, and they all looked okay, no unusual readings. And then I said, "Okay, go on up to 750,000 pounds load." And so I could hear the machine start up and shiver and shake a little bit. And all of a sudden I started hearing some ping, 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 which is a dangerous signal. And before I could say anything, crash! All of a sudden a loud snap like a rifle shot, and the whole machine shook. And I looked in there, and there was those big machined webs broken. And so that was the end of the test, and the flexure had broken. And Mr. Ormond stood in danger of bankrupting the whole company, the bankruptcy of the whole company, because of the amount of loss that would suffer. But he didn't do that, because he was a survivor. And what he did, of course, was well, I'm not exactly sure where I was in my story, but at any rate, Mr. Ormond recovered most of his costs by just simply charging each person with their what they would have billed him for their part of making those flexures. He charged them as if their work had some things improper in it that helped cause the failure, and rather than go to court about it, everybody ended up just wiping out all of the costs. But I'll never forget the experience I had of being 3 stories up in the middle of that huge testing machine and having that suddenly break right beside me within just inches away. And so that's my souvenir of that experience, that little piece of steel that came right out of the middle of that flexure. I have here also what's called a proving ring. This is the I can't even remember the name of it now. The reed, yeah, the reed from a proving ring, which is a gadget that we made and that I take quite a bit of credit for, having helped design. The Air Force was buying 2,000 of these proving rings. No, I'm sorry. They were 2,000-pound capacity proving rings. I believe they were buying 200 of them to equip testing labs all over the Air Force to check their force measuring equipment, some of their heavy presses and testing machines. And proving machines have been around, proving rings have been around for 100 years. And they're a ring of high strength steel with a micrometer in the middle, and this reed you flip as you turn the micrometer up until it just barely touches it, and you can hear a ringing sound, and that way you've known that this ring is being squashed at a precise amount, and that's calibrated and checked for force. The proving rings are made by one of 2 companies, Morehouse and Tinius Olson, and they've been made in the same way forever, of solid tool steel, just like these big flexures, all hollowed out, and so they cost several $1,000s a piece. I knew enough by now of high strength steel and the casting by what's called lost wax or investment casting that I told Mr. Ormond I was sure we could cast proving rings, and all we had to do was make the micrometer and the reed, and we could attach it on to this cast proving ring and make them for a fraction of the cost. We did so, we completed the contract, we made a good deal of money for Ormond, and I almost got to get one of those for myself, but I had to be satisfied with the reed. I left Ormond after not much more than a year and joined the John Deere Company. And I have a few things from John Deere, not the kind of things that reflect directly the work that I did, because most of what I did was planning and organizing a new research laboratory. And I did a really creditable job of planning out the concept of a research laboratory and of the way it would be laid out and the different kinds of functions. But then they decided, before I got to go with it at all, I was to be the liaison between the company and the Eero Saarinen architectural firm that designed the new administrative building that John Deere has now been in for 30 years. They decided, rather than build a new research laboratory, that what would happen was to stay in the building that we were in, down right on the banks of the Mississippi River, that had formerly housed the advertising department of the company before they moved into the new administrative center. And so I wasn't able to develop any of those ideas. However, I do have this little box of John Deere tractors that represent the milestones in tractor design from the old Waterloo Boy single-cylinder upright engine, which was the first. The Waterloo Boy Company was bought by John Deere, and that became the first John Deere. And this was a 1892 Waterloo Boy. I'm sorry, I make a mistake. That's the Freilich tractor, which was before the Waterloo Boy. Then here's the Waterloo Boy 1914 model, which had a horizontal cylinder, a huge horizontal cylinder. And when that was bought by John Deere, then John Deere produced the 1923 Model D, which was the first one with the two horizontal cylinders, which then continued clear on up till after World War II. In fact, that two-cylinder design with horizontal cylinders and the horizontal sideways crankshaft continued clear up through 1958 and 59, when they finally came out with the new 4010 tractor, which is one of the most famous farm tractors that's ever been made. Another thing that I did was to coordinate with a professional advertising group who produced this brochure about the John Deere Research Organization, and I coordinated all of the photography and edited the text to make sure that it was proper. Then I had one personal little project. I felt I was given the opportunity to decorate the lobby of our research organization. We had a very plain building, and I wanted to make it something special. So I conceived the idea of a beautifully designed curved wood paneled bulletin board with a frame on which we would put little succinct sayings having to do with research and with creativity and thinking. And so we did that, and we'd change them every week or two. And I received lots of comments about those. Be interrupted a moment. So I conceived the idea, since we started getting a lot of people's comments about these neat sayings that I was putting in the frame, that I would work up a little brochure that had a brief introduction to our research organization, and then first of all, a brief introduction to John Deere, a brief introduction to the research organization, a listing of our officers, and then open up the brochure and have a selection from the best of these. One of them that I got was this picture of Winnie the Pooh bouncing down the stairs on his head behind Christopher Robin and saying, "Here's Edward Bear coming downstairs now, bump, bump, bump on top of the back of his head behind Christopher Robin. It is, as far as he knows, the only way of coming downstairs. But sometimes he feels that there really is another way if only he could stop bumping for a moment and think of it." Then, of course, we have many from noted people like Harry Ferguson, who said, "Beauty in engineering is that which is simple, has no superfluous parts, and which answers exactly its purpose." Well, Dr. Millar, the director of research, said, well, maybe that would be okay. Submit me an idea for what you would have in it. And so I wrote it up, and he said, well, fairly good, but it needs some more work. And I ended up rewriting this 9 times, at the end of which he said, you know, that's really good and that's worth publishing. And so we published it in this form with a double-page spread and with this cover on it, and gave these out to the people who came to the company as visitors. And I have several copies, which I have given to each of my children and their families. Have one more little goodie here. We had a lot to do with other suppliers with other people in the automotive and farm machinery industry, and often with suppliers. One of the salesmen from the Saginaw Steering Gear division of General Motors brought this little demonstration unit for their recirculating ball steering gear, which is a little gadget. It's getting kind of old now and won't always go, but you can just hold the nut and it threaded its way down through it. Isn't that neat? Let's see, I guess it goes one way and not the other. I'll have to turn it down this way, and then I can turn it over and just hold it, and its own weight allows it to wind its way down through. And I asked him if I could get one of those demonstration units, and he gave it to me, and I still have it. So much for John Deere. Here's a personal thing. This is the camera that I carried all through the 1960s and 1970s. An old German one. You pull the lens body out, turn it to click to make the depth of focus far enough, and then you put it back in to make it more compact. We do that now with just a more sophisticated lens design. This was an inexpensive old camera, but did a very good job for us. Until one time, we were on vacation up at a lake I believe in Wisconsin, and I had the camera in its bag, in this little case, and I had it hanging from my neck. Had a long cord on it and had it hanging on my neck down in front. And I climbed over a fence that was right by a boat dock at the edge of a lake. And as I climbed over the fence with this around my neck, the camera dropped down on the other side of the fence. And as I hopped down onto the dock, the camera flipped up over my head, came off my neck, and went right in the water behind me. And I looked down, and there I could see it right down in the water, about 2 feet underwater. And so I hurried and got down, laid down on the dock, reached down in the water, pulled the camera out, and I hurried and took the film out of the camera and opened it up and shook all the water out of it, and then left it out in the hot sun. And lo and behold, after a day or two of drying, I tried the thing you always worry about is that the shutter will rust up because it's all kinds of metal plates. And sure enough, when I tried to run the shutter a day later, why, it was stuck. But I pushed a little extra hard on the shutter and it started working, and the camera kept working for several years after that and didn't give me any further problem. And I even ended up sending that roll of film in and saved half the pictures on that roll that had fallen in the water. So it was a very good experience. I have here, there's another little break, my coin collection. Most of these coins are United States coins. And some souvenir things. For instance, here's a coin from Thomas Jefferson that I got at Monticello, Virginia.
Thomas Jefferson?
I have some, I'm taking a video now, so don't talk, but you can if you need to ask. And so I have all of these coins that I've gotten from various exhibits and other things. However, I have 2 silver dollars.
And most of them. I don't get
They're
mine.
mostly American ones.
Do you have
If
any
you
half
talk, you
dollars?
have to talk loud so that the video can
Do you have any half dollars?
I have some half dollars. And these are silver dollars. Let's see, no, those aren't silver. Those are copper dollars.
What's the difference?
But, well, like
The
pennies,
big
they're
dollars.
made like pennies. They have copper in the middle and just a thin amount of silver on the side.
Yeah.
But here are some half dollars that are all silver. These are called Kennedy half dollars. And here's a Franklin half dollar. And they're all silver, and so they're worth $10 or $15 now.
Do
And
you
then I
have any coins from Mexico?
I have a bunch of Mexican coins, and here's one from Great Britain, or excuse me, from Canada. And then I have a couple of old American coins, including if I can find it, a 1837 American penny. And it doesn't look like I have it here. I wonder where it is gone. Because it's a large coin about this size that's copper, but I don't see it.
About the size of a nickel?
But
Do
here
you have
is,
any coins out of this country?
well, I have some from Great Britain and some from Canada, some from Mexico, and
Do you have any from your mission?
well, my mission was here in this country. And let's see, here is one that says United States of America. This one is over 100 years old.
That means it was made in 18 something. Or maybe 19, but it's
No,
almost.
I'm sorry, that isn't. This is a Philippines 1 centavo piece. So it's the United States of America, country of the Philippines. Because you
I
see,
didn't know
the
the
United
Philippines
States
was-
used to be owned by the United States of America. So I have all of these interesting coins. Here's one from Italy, and here's one from Canada, and several from England, and here is a streetcar token from Salt Lake City.
What? A beehive.
Streetcar token, that
You
means
see
it
lots
could
of
go on the
beehives
street.
near Utah in
Street.
Salt Lake City.
That's right. And that was a streetcar token. Okay, now be kind of quiet. The next thing that I have gets back to my business experience. I have samples of business cards that I have had over the years, and of course, the first one, the first sample that I have, the first sample that I have, pardon me just a moment. Could you people please close the door? And the first one that I have, of course, is my missionary cards, which have the Articles of Faith on the back and have my address, Southern States Mission, 485 North Avenue Northeast, Atlanta 5, Georgia. At that address now, there isn't a building at all. The old Southern States Mission headquarters has been completely demolished and is gone now, and there isn't anything on that street at that point.
Why?
And then here's my home address, 1166 West, 4800 South, Murray, Utah. And of course that house is still standing and is still being lived in by the family that my parents sold it to. The next card that I have says R.D. Collier, Supervisor of Engineering at the New York Aircraft Service Shop of the General Electric Company. And that was the first job that I had after leaving the General Electric training program in Linden, New Jersey. The next one I don't know where the copies of the cards are from the both my time as an engineer at Los Angeles Aircraft Service Shop. I may not have had cards then, but then I had cards as the engineering manager at Ormond, engineering director, and I don't have them. Here is my card for being a staff member at the Engineering Research Department of John Deere. And then here are cards for my being manager of capital budgeting planning for Deere and Company in Moline, Illinois. And then here are cards from me being the manager of industrial product design at Taylor Instrument Company in Arden, North Carolina. Then here are cards from me being the Executive Director of the International Association of Quality Circles in Midwest City, Oklahoma in 1983. And then after I returned back to North Carolina, I was a temperature measurement consultant for a while and made up these cards for my own use at 2 Deseret Drive, Arden, North Carolina, offering accuracy assurance, National Bureau Standards, traceability establishment, temperature metrology, writing and training, and expert witness service. And then here finally are the cards that are the ones I had when I retired as supervisor of the Asheville, North Carolina PM group of the Church of Jesus Christ of Latter-day Saints.
A what?
Somewhere in 19... The next thing I have here is this thermometer case. This is one of the old Taylor 5-inch thermometers. And I took this thermometer case, beginning in 1969, I took a sheet of paper and got all of the school pictures of the kids and a photo of Rayanne and put it in the case. And then each year I would change the pictures as their school pictures came and as we got baby pictures of the little ones. But then up through let's see, I guess the last year was in 73 when Ted was born, and I finally had a picture of every one of them. Let me bring it up a little bit closer so you can see it, I hope. And I finally had everything in a beautiful picture of Rayanne, and so I just have kept it the way it was in 1973. As you can see, these pictures were done with the film that they tried to change to not use silver anymore in photo film, and they faded very quickly after, and they don't use that formula anymore, and so these are somewhat faded, but there's a picture of all of our family as of 1973. Well, that introduces my coming to Taylor Instrument Company. Now for Taylor, I really have quite a large number of things that come to mind, but I'll mention 2 or 3 particularly. I came to Taylor because they wanted to completely redesign and needed an engineer to redesign the bimetal thermometers. That's these thermometers that have a stainless steel case and a stem in which is a coil of bimetal that has two different metals of different expansion ratios welded together and then rolled out into a thin strip so that when the temperature changes, they curve. The bimetal bends, or if you have it wound into a coil, the coil will unwind and wind up. This is the old style. This is the 3-inch one. It had a snap ring here and a glass that fit inside, and then this is the 5-inch one. They asked me to redesign those completely because they just were not competitive. They only had perhaps 1 or 2 or 3% of the market and were hardly worth keeping on making. My first job, and really the job that established the peak of my engineering profession, was the 1-inch bitherm, and I want to talk to you a little bit about it. But I should mention first this one, which is called the Kentucky Fried Chicken thermometer. I'm going to move it away just a little bit so that I get a better light on it. This was a thermometer that we made for the Kentucky Fried Chicken Company, and it was used for a time in every Kentucky Fried Chicken store. And just as I arrived to go to work, they were starting to have a lot of complaints about the new thermometers. We had to make a lot of them because they typically got lost or broken or damaged because they were used very hard. These thermometers were put in the fry kettles, which were just 6-quart ordinary pressure cookers, into which they they heated cooking oil to 400 degrees in these kettles on gas burners. Then they dumped a load of chicken parts into that 400 degree fat. This thermometer had one mark for 400 degrees and one mark for 250 degrees, because when it cooled down to 250 degrees by all of that chicken having been thrown in, that was when you put the lid on. And Kentucky Fried Chicken cooks by steam made from the moisture in the meat itself. You don't add any water at all. And so you put this in, waited till the temperature of the oil got up to 400, but not anymore, or it would start to darken. And then you stirred it and made sure that the temperature stayed above 250. I think you stirred it for 11 seconds to brown it, something like that, and then put the lid on and pressurized it. Anyway, they had started having real trouble because the pointer would stick at various random places. It wasn't moving smoothly at all. And so they sent me out to find out what the matter was. And I quickly brought back some samples. I had an interesting opportunity to learn how Kentucky Fried Chicken stores operate and what they were doing with them, and did a bunch of trying to find out what was the matter in stores in Atlanta, Georgia, and also down in Chapel Hill in Greensboro, and got acquainted with a number of the managers, and it was a very interesting experience. But then I quickly discovered that the problem was inside the thermometer itself, and it didn't take me very long to find out that the problem was that in the buffing operation for cleaning off the stem after it was all welded and fixed up, they were leaving this cover off, and some of the buffing compound, little granules of abrasive, was getting down into the bearing, this little center area, which had some silicone fluid in it, and they were getting caught in that, and then they were catching and stopping the stamp. And so it was an easy thing to fix, and I got quite a bit of credit for that. Then I went to the design of the new thermometers. Well, the first thermometer that they wanted me to work on was this little pocket thermometer. I don't have one of the old Taylor ones. It was considerably bigger in diameter than this, but was not easy to read at all because the numbers were too small and too light. The lines were too light, and it had a number of other problems. Once you dropped it on the floor, it was no good anymore. And of course, being a pocket thermometer, it's bound to get dropped on the floor. I was able to look at the whole concept in a way that nobody had ever looked at it and decide, okay, what would the ideal thermometer be like? And I started from scratch. And all of the experience I had had all through my life with building things that were practical and sensible and worked, and knowing what to look for to decide what needed to be done to make something the best way possible, just all fell into place. And it was one of the most satisfying experiences of my life. Furthermore, it was one of the most successful because I was able, there were 5 different competitors for this kind of thermometer on the market when I started my project. I started my project, put the new thermometer into operation just at the time that the fast food business was taking off, and all the McDonald's stores and the Wendy's and the Burger Kings and all of the heating and refrigeration servicemen were changing over from glass thermometers to these bimetal thermometers because they're so rugged and durable. And so all of a sudden these started selling by the millions all over the country. And we started in 5th place among 5 competitors, and 5 years later there were 10 competitors and we were in 1st place. And as far as I know, that design, which has not been changed by Taylor since I completed it in 1970, and is still being sold exactly the same thermometer, building of the same components. Now, 25 years later, is still the #1 seller on the market and still sells several $1 million worth every year. So it's been still is a very satisfying thing. Not only is the #1 in sales, but a number of foreign competitors did me the honor of photocopying the dial and making their dials identical to mine except for the manufacturer's name, because they liked it so well. Furthermore, one of the other features of it, this little pocket clip, which not only functions as a pocket clip to hold it in your shirt pocket, but it also functions as a little loop to hold the handle and keep you from burning yourself when you're putting it in something very hot. But it also has this loop continue on down the inside, and it holds the thermometer in the loop. That idea of making one like that was not new to me. One of the other competitors had that, but theirs didn't work very well. This was too hard to push in, and it often got so that it scraped the side of the thermometer, and then also sometimes it wouldn't hold it. And so my design worked so well that at one point in time, all of the other American manufacturers had come to us and requested to buy these clips from us or from our supplier, which is a company up in New England that makes these on what's called a 4-slide metal forming machine. And so we charged them a royalty of a half a cent a piece and told them they could buy them from them. And that gave us the rather interesting experience over a several-year period of knowing exactly how many thermometers each of our competitors was selling, because we got a royalty from our supplier for each of these clips that they bought, and so knew exactly how many they were selling each year. Well, let me tell you a little bit about how some of these worked. I will illustrate from this thermometer. The first thing, and the most important thing, was when you have something this small, the toughest thing about it is reading it. How do you read it so that you can read what the temperature is when the whole dial is only an inch across? Well, I looked at it and I said, well, first of all, the first thing you want to do is to have the marks be right out at the very edge. You sure don't want them way down here in the middle and a lot of space out here. You want the scale to be as big as possible. So the first thing I did was design a case where the metal cover, the metal ring around the edge, didn't come in at all, just came up the side, and it only curves over the top far enough to come in the thickness of the plastic crystal and no more. So the dial is right out at the very edge, and it can be seen through right to the very edge. So that was the first thing I did, and that took quite a bit of work because that has to do with metal spinning. And the first time I tried to do metal spinning, I didn't know anything about it and it didn't work well. And so we had to spend an extra $2,000 for some new tooling and a new shape for this plastic lens in order to the idea that, frankly, although you have 10 marks in between each set of numbers, you don't need to count those marks. Your eye can judge a position of the pointer as to whether it's 1/10 of the way, 2/10 of the way, 3/10, 4/10, 5/10. So I put a great big wide, bold mark, narrow right where the pointer touches, but flared out towards the outside so that it was very easy to see where the mark was that goes with each number. Then I put a slightly smaller mark halfway in between, so now you only have to guess to 1 part in 5 parts. And you can frankly learn to just glance at this and see. I can look right now and I can see that that says it's just about that. The 2 marks are at 50 and 100, and I can see that it is slightly below the midpoint, or in other words, it's about 72 or 3 degrees. More than 70, less than 75. Then I spent quite a bit of time designing the numbers, picking, I should say, a typeface. It turned out that I wanted fairly thick, bold numbers, but I didn't want them round. I wanted them compressed so that they wouldn't be so wide. And so they're compressed and extended vertically, and it's called a condensed typeface. And I picked the one that would look just right. And the way I did that was by making samples of dozens of different typefaces, putting them on a wall so far away I could hardly see them, and seeing which one I could see the best. People to come and look at them and say, which one of these can you read the best? And we got to where they would all pick the same one, and so that's the one that we chose. Then I made the dial so that on the small dial, it has to be flat, but on the larger dials, add a little step in it so that the pointer almost touches the mark and you can read it accurately. And then the final thing that I did was spend a lot of time designing the pointer. The pointer has a straight section right out near the tip, and that's identical on this little one, that you can barely see because it's quite fine, but you know exactly where it is because you have this nice wide V wedge of a pointer on the other side. The back end of the pointer is cut off right exactly at the length where, if you balance it about this center point, it weighs exactly the same from here to here that it weighs from here to here, so that when you pound it down, bounce it up and down, it doesn't wiggle back and forth, which it would be if it wasn't balanced. It's perfectly balanced and tapered for maximum visibility. Those were some of the considerations. Then the next thing that made this what is still by far the most easy to read thermometer on the market. Since we made it this way, anything else that anyone else came up with that was very easy to read looked very much like ours, and so others have had to make theirs less readable in order to be any different. The next thing that I did, I actually copied most of the stem and this adjusting nut, which allows you to hold this with a pair of pliers and turn the case to change the calibration. That was as well done as anyone could do that I thought, and so I copied that from competitors. But then the next thing was this matter of dropping it. I just had a hunch that the next thing that would matter was that it needed to be able to be somehow shock protected so it could be dropped, and that thin coil of bimetal would not, when it hit the ground, hit against the side of the stem and bend slightly, because that would make it a different length, make it turn a little bit and change the calibration. Well, I quickly got the idea of using a silicone fluid that's very inert and that can be bought in any thickness, any viscosity. So I